Hi there once again and welcome to another Expresso mechanic tutorial. And in this one we're going to be looking at making this. I'm calling this a lazy align to spline, and it works in a similar way to the standard align to spline, except that the sphere is allowed to move around and it doesn't follow the spline precisely. Now you can see that we've got a green line between the spline and the actual sphere, and that acts like a tether. So the sphere is only allowed to go a certain distance away from the spline, and then the tether actually stops it from moving any further. Now to achieve this, we're going to use the get nearest point on spline node within Expresso, along with some Python in order to make this actually work. We'll also add some user data to control the amount of offset the tether actually allows the sphere to have. So we're going to use a few different tricks in order to get this to go. But anyway, that's what we're about in this tutorial. So without further ado, let's see if we can make this happen. The first thing we need to do is bring in a sphere. So we'll grab one of those and make it 20, I think, in the radius. That will do. We can leave the segments and everything else. We can leave that the same because we're not going to change anything here. So that will do nicely for our sphere. So that's brought that into the scene there. Moving on from here, I'm going to hit function 2 and switch to my top view. And we'll start thinking about creating a spline. Now this doesn't have to be anything clever either for our purposes here. We can just produce a simple spline. Something with about 9 points I think will be perfectly adequate for this. So that's 1, 2, 3, 4, 5, 6, 7, 8, and one more is 9. That should do nicely for us. We can hit escape, go back into our 3D view, and we've got our spline and our sphere ready to go. What I'll also do for our purposes here, I'll just pick up my spline and move it so that the point is, or the first point is almost at perfectly at 0. That'll be okay for what we're doing here. And then the sphere, we can just move that back to 0, and that's fine. So our spline and our sphere are set up. What I'm also going to do with my spline is just come into my basic tab here and hit automatic, and I'll just make that a sort of orange colour. So let's just make that something somewhere around there. That'll do nicely. Our spline is constantly orange then, and we'll always be able to see it, which is great. And the sphere, let's just make the sphere a purple colour. See if we can do that. Let's just find out what we've got here. Somewhere around, it's a bit too dark. Let's go a bit brighter than that. Somewhere around there I think will be okay for a purple. Yeah, that'll do nicely. Okay, so we've got our sphere and we've got our spline ready. And that's about good enough for our first manoeuvres. So we can think about moving on from here. First thing we need to do then, grab a null, change its name to Expresso. We'll give it an Expresso tag. And we're ready to start thinking about doing a little bit of work. Before I start dragging anything into the Expresso editor, I'm just going to rename this spline path. Select both the path and the sphere and then drag both of them in. Just set them up over here. Now let's get the all-important node in and we'll see what's going on there. So the node that we need is the get nearest point on spline. Quite a mouthful, but that's the one that we need. Now we can give our path an object output port and plumb that into the spline object. And we can give our sphere a global position port and plumb that into the global position. Now, as you can see, the get nearest point on spline node actually has a number of inputs and outputs. Again, it's one of those nodes that you can't add to or take away ports from. It's just, it is what it is. But it's quite a powerful node and will allow you to do a number of different things. The precision, as we can see over in the parameter here, the precision is set to 1000. We don't need to change that unless the spline is incredibly long. Then you may need to up that number, just increase it by X amount in order to get the precision to be a little bit better. The spline segment and all segments, we don't need to worry about those. We haven't got a segmented spline, so it's only got a single segment, so there's no point in worrying about any of that. We don't need to check the box or increase this value in any way. At the output stage, we've got the spline position, which is a value between 0 and 1. That's similar to the align to splines position value, which of course internally is calculated as a number between 0 and 1. The nearest point is the one that we're going to be interested in here. That's the one that we're going to be using in order to make this work. So that's the all-important port for us. The nearest segment, we don't need to worry about that again because we haven't got a segmented spline. And the tangent here is the tangent of the nearest point on the spline. So if we go into points mode and we select this point, these tangent values here are going to be returned as a directional vector. Now that may have its uses elsewhere. We don't need to use it in this particular example, but if I can come up with a scenario where this might be useful, I may do another tutorial featuring this node a little bit later on. But we'll see. That I found that quite interesting, that was a directional vector. So that could be quite a useful thing to have a play around with. But as I say, for now, we don't need to worry about it. But anyway, that gives you an expose of the get nearest point on spline and gives you a few ideas as to what it kind of does. But you'll see a little bit later in the tutorial exactly what it's going to allow us to do. The next thing I need to do is create another spline. So I'll click off my path just to deselect that, grab my pen tool, and there's just a couple of points that I need on that spline, and I can hit escape and deselect that one. What I will do though is change its color, go to automatic here, and then just change its color to green. Actually, we'll just give it a nice green color so that it shows up nicely. That will do perfectly. Okay, great. So this spline is going to be the tether that's going to connect the sphere to the spline, or to the nearest point on the spline as the animation progresses. That's what we're going to use this for. So we'll rename this spline connector. Didn't really need it all in caps. Connector. That's fine. Okay, great. So that's ready to go. So we'll pull this into the Expresso editor here, and we can give this an object port at the output stage. Moving on from here, we need a couple of point nodes. So we'll come into our general menu here and grab one of those, give it a point position port at the input stage, and then we can command drag to create a copy. And just move these down a little bit. That's fabulous. So I'll connect the output or the object output from my connector spline to the object input of the point node, and as soon as I do that for both of them, my points are both connected. And if I increase the index value to 1 for the second point node, as we can see, both of our points are now, they've disappeared, but they haven't. They're here. They're at ground zero, because obviously their point position vectors are completely zeroed out at the moment. So that's where they've gone. So let's move on from here. Now my sphere, I've just moved over here, and I've done that deliberately just to show you what's going to happen. If I connect my nearest point to the point position of my first node, nothing's going to change. But if I connect my global position, and we'll just make that a bit bigger so that we can see that that says global position, to the point position of my second point node here, so the point 1 effectively of our spline is going to be connected here, straight away we can see what's happened. The connector is now set to the center of the sphere and the first point of our spline. So it's connected the two together, and that's what we've wanted to achieve here. And once we start the animation, this will be used as the tether that holds the sphere at a certain distance away from the spline all the way through the animation. It won't let it go beyond a certain distance that we're going to set. So we've got the first part of this nicely set up now, and it's all working. The next step, and in many ways it's the key step, is to bring in a simple polygon. Now, why are we doing this, you may ask? Well, I'm interested in the normal direction of this polygon. That's why I'm doing it. I was going to make it smaller, so we'll come into the object. We'll make it something like 20 by 20. That should be fine for the size. And the orientation, well, we can make that. I think we'll say +X for now, though we may need to change that later. It doesn't want to be a triangle. Don't worry about segments. That's all perfectly good. And what I'll do, I'll come into the basic tab again, automatic, and this time I'm going to make this yellow. Somewhere around there. That'll be a nice colour for it. That'll do nicely. Yep, that's fine. And what we can also do, we'll go into Garrett shading lines. So that way we can see everything more clearly. All good. So we've got our polygon in there, and what we'll do, I'll just move this and make it a little bit bigger. And I'm going to drop my polygon in above the connector here. And once again, I'm going to give this an object port at the output stage. And I'm also going to bring in a polygon node. So we'll grab a hold of one of those, connect the output to the input there, and that's set up. And at the output stage, I want a polygon normal port, because as I say, that's what we're interested in. And then the next thing that I'm going to be interested in will be a vector to reals. Bring one of those in, so we've got our adapter there, and then we can plug the polygon normal into there, and that's all good. At the moment, we've still got a yellow top on our polygon node, and the reason for that is because we need to select the polygon here and simply hit C to make it editable, because the polygon node works with geometric objects as opposed to parametric objects. And that's fine. That's all set up now and ready to go. Our next port of call then is to rename this polygon, and we'll call it target. In fact, not Tragit, target. Learn to type. There we go, target. Next thing we need from here is a spline node. So we'll come down to there and grab one of those. It's got a position port. We also need it to have a length port, which we'll be using a little bit later. And we can plumb that from our connector into there. And then we can get our target, bring this in, and give this a position port. And plumb that in like that. So that's sorted. Now what we're going to be doing here, so the connector, we've got the connectors here. The point we're interested in is going to be this one. So our connector is going to pass its position to this target, and it's going to be carried along the spline, and that's what we need to happen here. So that's why I've done this. The next step is to give the target a target tag. So let's do that. Let's get an animation tags target. And this target tag is going to be given the sphere as the object that it's going to look at, because I want this target to be looking at the sphere wherever it moves at all times. That's very important, because that way we can get the normal of the actual target polygon, and it will always be facing in the direction of the sphere. And that's going to be very, very useful to us in order to make this work. The next node that we need to bring in then is the all-important Python node. So we'll come down to script and select a Python node. And this is going to be the thing that makes all of this hold together. This is the sort of the thing that it all hinges on, really, the Python expression that we're going to be putting in here. As always, I'm going to remove the ports and we'll start from scratch. So delete all of them and start from scratch. Just view that at 100% once again. That's good. And just move everything over a little bit. Right, so let's start adding some new ports and see where we go from here. So the first thing I'm going to add is a float, and it's going to be called normal direction _ direction. That's our first port. Second port will be another float, and I'm going to rename this length. Moving on from here, I want another float, which will be pos underscore z. And finally, I want an integer, and this will be renamed frame. And as you've guessed, we are going to be using a time node. So that's our input stages, or all set up. So that's all working as it should. At the output, I want another float, and I'll rename this sphere pos z. Make the node a little bit bigger, and we're ready to go and start coding. So we'll move to a coding layout. Change this to Python in here so that we're ready to go. Just go back into our Expresso, reselect our Python node, and we're ready to start doing some work. So we'll open the Python editor. Okay, and we can take away this line straight away. We don't need that one. So we've got global position Z in there, which is fine. We need that one. And we also need global direction. That's the first thing we need to put in there. Before we move on, let's just view 100% so that we can see things a little bit more clearly. And I'm going to resize again so that I can get all of the nodes in. I did say that we needed a time port, and I'll get one of the, or a time node, I beg your pardon. I'll get one of those right now. As per usual, take away the time output port and replace it with a frame port. That's ready to go. Now this frame, straight away, I'm going to plumb that into the frame of the Python node so that we've got that there. The next thing I need to do is give this sphere node here a position Z output port. Just make it a little bigger. And at the input stage, I'm also going to give it a position Z port. Or rather a position X port, I beg your pardon. That just sets that up as I need it to be, because I'm going to put a range mapper in front of it actually, and I'm going to be using the time node to control the range mapper, but we will do that a little bit later. This position Z I'm going to place into there, so that's connected as it should be. The normal direction we can get from the vector to reals here, so we can plumb that one into the normal direction. And finally, this spline length here is what we're going to need to plumb into the length over here. So that's the input stage of the Python node completely set up, and we're ready to work with it. So let's start doing some code. Right, so my first line of code is going to be if frame is equal to, and on this occasion it's going to be 1, direction is equal to 1, square brackets. So we're setting up our direction list here. You'll see why a little bit later. We have to use frame is equal to 1 here, because frame equal to 0, it just doesn't work, and I'm not absolutely sure why that is, but on this occasion it doesn't. It doesn't really make any difference to the animation. There's nothing detrimental to it here. We just got to start from frame 1 as opposed to frame 0, so it all works fine. Okay, so the next port of call then is to say if length is greater than or equal to. And what we're going to do here is actually use some user data. So what I'm going to do first is actually go into my Python node here, just select this node, come into user data here and say add user data. And this data, I'm simply going to call it length, or rather offset. In fact, I'll call it offset because I think that makes sense. So we'll call this offset. It will be a float. We'll give it a float slider, and we'll give it a value which is, or a unit value, which is going to be a real value. The step I'm going to change to 0 or 0.01, so we're just going to say 0.01 in there. The minimum will be 1. The maximum I'm going to set to 30. I'm going to give it a default value of 10 and check the slider min and slider max. And then that's all set up for us and we can click OK. So it's here, it's down the bottom here under the editor window. I can then drag this in and place it here. Remove the word Python and replace it with op. So we're saying then, if the length, which is coming from, of course, the spline here, so what we're saying is if this connector's length has exceeded this value in here, so that's where we're able to control the actual offset value of the spline, or rather the sphere, I guess is what we're saying here. And that's how this is going to work as a tether. So as soon as this spline length is greater than the value that we've set as our offset, we're going to do something and we're going to make the sphere, in fact, change its direction. That's what we're going to be doing here. So let's continue from here. We can then say if normal direction is less than 0, direction dot clear, because we want to set this back to an empty list every time we need to change direction. So we'll do that there, and then we can say direction dot append 1. And then our output stage, we can say sphere pos z is equal to pos z, so it's equal to the current position plus direction brackets 0. So if our normal direction, and that's the normal direction or the direction that our target is facing in, if that direction is less than 0, so in other words, if it becomes minus whatever, then we need to change the direction of our sphere because it won't be moving in the correct direction at that point. So we clear out this list here. At the moment it's set to 1. And then we simply append the direction with 1 on this particular occasion. So that's if it's less than 0. That does, so the fact that it's already 1 is irrelevant. It doesn't matter. We still have to change that to 1 again. It doesn't matter. And then we simply give the sphere output position, or the output port here, the sphere position Z. We give that position Z plus whatever the direction happens to be. Okay, so initially the position Z is going to be 1. So that's why we're doing this. That's what we're doing here. The next part of this is to say if normal direction is greater than 0, we can copy this code and just make some adjustments within it. So we'll copy this code, we'll place it here. Again, we need to clear it out, but on this occasion we need to change the 1 to -1, and the rest can stay the same. That's all we need to do. That's the only change we needed to make in there. So if we were traveling in a positive direction, we now need to travel in a negative direction, and vice versa up here, whatever is happening. So that's all we're doing here. We can then finish this off with else. And again, all we need to do is copy this line, paste it in there, and that's working okay. Now this else, in actual fact, is not quite at the right level, so we need to take it back to here. So if none of this applies, or rather if the length isn't greater than the offset value that we've set up, then we can just say keep on moving in the direction that you're currently moving in, and we've got an initial direction of 1. Okay, and what we're going to be doing here is actually moving the sphere along this Z axis here. We can see the Z axis, the blue line here. So we're going to be moving the sphere backwards and forwards along its Z axis as it travels along its X axis. Okay, that's what we're going to be doing to control this. So that's all of that Python code is now in there, and it's set up and ready to go. It's a pretty simple expression that we're using in here, but it's the key to making this work, as I said earlier. Okay, so that's our coding done, and we don't need to do any more in there. Actually, there is one thing I've got to do. I've just got to correct this spelling mistake because I've got POZ instead of POS there. I've just noticed that. Okay, that's all good. Everything's sorted in there now. Right then, the next step is going to be to go back into a standard layout for a start. Bring the Expresso editor back open and resize once again, and we'll see where we go from here. Just take this back to here so that we can get everything on the screen. Okay, I'm going to move my time node over here, and I'm going to bring in a range mapper. Come down to calculate range mapper. Just bring that in there. Okay, I'm going to plumb my frames into here and view 100%. That's better, or will be when I get it to do it. That's it. That's sorted that. All looking perfectly good. My frames, I've got 90 at the moment. I'm going to set that to 500. And in my range mapper, I'm going to say input upper, set that to 500. Now my output lower, let's just see what we need for the output and output lower and upper. We've got our sphere. Now we're going to set my sphere to, let's just select model mode. I'm going to set my sphere at 0 on the X. In fact, let's just go into view 2. I just want to see where I am. Going to the top view, I should say. Yeah, my X is set to 0 now. I'm going to just move my sphere by eye to somewhere here so that it's just about 0 position. And we'll also make it 0 in the Y. So that way it's pretty much zeroed out. In fact, we'll just zero it out completely. Why not? That should be okay. And then what I've got to do is work out where I need it to go by the time we get to 500 frames. So let's just grab a hold of it and move it along the X-axis here. So it needs to go to somewhere around 650, somewhere around there. So that should be okay. So what we'll do in this range mapper, if we say 0 to 650, that should be fine. And we'll work with that. So let's just take this back to 0. If it doesn't work, we can always change it. It's not a problem, is it? Okay, so we'll plumb the output of the range mapper into the position X of the sphere. And that's all looking good. Again, I'm going to just view this at 100% so that it's clearer. So that's all set up for us. The next thing I'm going to do is just put a check in here. So I'm going to get myself a compare node, place this here. The function does need to be equal to and the input to 0 because we're going to be using the time node or to compare our frames to 0 so that it's just the standard check to see if we're at the start of the animation. So if we're equal to 0, all we then need is a condition node. Bring in our condition. So if we're equal to 0, we're going to switch our condition and we're going to leave input 3 at 0. Otherwise, we're going to be using the position Z or sphere position Z from the Python node. Okay. And then all we need to actually do now is bring in our sphere, give it a position Z port at the input stage, and then connect the output of our condition. And that completes the Expresso node now, or the Expresso expression I should say. If I just frame all so that we can see it. So that's the complete expression. That's everything we need to do in order to make this work. So the moment of truth, let's see if it actually does work. So initially it certainly is. Let's see what we're getting here. Yeah, it is. It's doing what it should be doing. It is making our sphere behave in a very erratic sort of way, and it's pulling it along the spline with an offset. Yeah, that is doing what it should be doing. However, it does need some refinement. What we're going to do first, this polygon, it's actually aligned facing along its x-axis, and it should really be on the z. So what I'm going to do, I'm going to get another polygon, quickly set it up so that it's 20 by 20, and I'm going to orientate it plus z, or rather as opposed to plus x. In its basic, I'll make the colour yellow again, something like that will do nicely. And then what I can do is place the target tag on this one, get rid of the original, call that target, and then go into my expression and drop this into the appropriate places, which is there and there, and that should be okay. Let's have a look, see what we've got here. Make doubly sure. I see why it's not working, because that needs to be editable, and now we've got it. That's perfect. Okay, so let's see what we've got now, see if we get anything slightly different. So yeah, a little bit different. We've still got our object moving along our spline, and you can see now that the actual polygon is actually facing the sphere. That's doing what it should be doing. Now the shape of the spline is playing a role in this. At the moment it's perhaps not as good as we'd like it to be, but it definitely is working better than it was. Let's go into our top view, so function 2, and let's see what we've got. So our spline, yeah, if we go into points, we can just do a bit of refinement here. Just bring this down a little bit, bring this one down a little bit, perhaps bring that a little closer. Something like that may give us a better results. Just that little bit of refinement. Let's see what we can do here. I mean, again, this is an art direction thing. You may not agree with me, but I think this will probably work a little better. Yeah, you can see it's being bounced around, and it is now following the spline erratically, which is what we want. It's given us that, but that's a better behavior. I think that's better. To me, that looks better on the eye. It's more pleasing to my eye than it was before. And this is what you've got to bear in mind with this. You've literally got to sort of fine tune this until you get the result that you want. But that's good, that's working. If we open up our expression here and we select our Python node, we've now got our offset available to us because we've got the user data there. What I'll do is just lock that, and then if we go back to the beginning, we can start having a play around with the user data and see what happens. So if we increase it, the sphere will now be allowed to travel further away from the spline, and you can see that it's got a bigger sort of tolerance there. So it's going quite a bit further away from it now, but it's still got the behavior that we want. It's still following the spline. It's just, again, doing it erratically, and it's moving further away before it's pulled back towards the spline again. So every time it exceeds the actual length that we've got in the offset value here, the sphere literally changes direction along its z-axis, because obviously the x is controlled by the range mapper and the time node. Similarly, if we make this much smaller, we can see that it's being reined in. If we take it right down there, it will follow the spline much more accurately. It's almost like a traditional aligned to spline. Not quite though, but you can see exactly now what this is doing. Yeah, it's much closer to being a traditional aligned to spline. Yeah. So that's it. You know, that's basically what I wanted to show you with this tutorial. Now, if we just unlock that again and open up the Expresso editor and just select frame all so that we're able to see absolutely everything. Okay, now if you wanted to work with, say, the normal direction of the Y and the X, you can. Just give yourself 2 more ports for the normal direction. You could say normal direction X, Y and Z for those ports if you wish to distinguish between them. And then just plumb these into those ports. And then inside the Python, all you've really got to do is essentially change, or rather just to add to this. I mean, instead of working with the position Z and sphere, sphere position Z, you can also add at the output stage sphere positions X and Y and have those there. And then you can just put the appropriate code in here and say sphere position Y is equal to pos underscore Y plus direction, and utilizing those with your normal directions for the X, Y and Z. So it's the same code, but with normal direction X, normal direction Y, normal direction Z, and then simply position X and X, Y and Z in these lines of code. That's all you've got to do. And then the same thing, you can have the 3 at the output stage and use them in combinations. There's that sort of things can be done quite easily. So, you're not restricted that way in having a spline that's aligned along the x-axis. You can have a spline that runs along the z-axis, and you can have another one that runs along the y-axis that way. So, you're not restricted in any way by this. It's just a case of adding a bit more code and a few more ports and things like that, and just working with that, because obviously you'd need to add here as well, position X, Y and Z, so that you can plumb those into here. So it's perfectly versatile. This is, it's not just restricted to one particular plane. So have a play with that and see what you can come up with, see if you can do something with it. But anyway, that's what I wanted to show you with this tutorial, and that is how you go about doing this. So I hope you've enjoyed this one and that it's been worthwhile for you. And if it has been, then please give the video a thumbs up. And of course, if you haven't already subscribed to the channel, then please do so and ring that bell. And of course, please leave a comment. And wherever you happen to be on social media, please share the video, because all of this good stuff helps to keep the channel moving in the right direction. But anyway, that just about wraps this one up. So I'll see you very shortly on the next tutorial.